Hello, and welcome to the fourth section of this course, which is called Azure WebJobs. Let us take a look at what this section will offer you. We will take a look at what webhooks actually are. Then we will familiarize ourselves with Azure WebJobs and how they operate. We will take the remote timer job concept for Sharepoint and see how it can be practically implemented using two different strategies. And lastly, we will explore how Azure WebJobs and webhooks methodology can organically be used to react to changes in a Sharepoint list or library. The first video is called WebHooks Overview. In current video, the WebHooks Overview, we will take a look at the concept of webhooks. We will examine which support Sharepoint currently offers for the webhooks functionality, and in the demo section we will configure Azure Portal to support our future code samples in the upcoming videos. In the world of web development, a webhook is considered a method of augmenting or altering the behavior of a web application, with custom callbacks raised from the application. In essence, this model allows external developers to subscribe their code to an event which happens in a web application. Contrary to the Application Programming Interface, or API, which operates on a pull model, this is a push model, meaning that the web application will be the one notifying subscribed endpoints by issuing an HTTP request to them, usually a POST request. Sharepoint webhooks functionality has hit general availability from 17th of January 2017, concerning the Sharepoint Online. In the roadmap, this functionality will also be available in Sharepoint 2016 on-premises. For now, only lists and document libraries, of course, are supported as a valid subscription targets. Let us take a look at Sharepoint webhooks subscription process. Firstly, our external application must issue a POST request to a certain URL in the Sharepoint. It's this one, API web lists with the GUID of a list /subscriptions. And we should include the appropriate object information here. We must note that maximum expiration date we can request is a period up to 6 months. Now, Sharepoint service doesn't want to allow anything to subscribe to it, and it instantly validates our endpoint, is it alive or not, and provides a certain random GUID in the validation token URL parameter, to which our endpoint must respond with the HTTP OK containing that same random string, which was the value of the validation token URL parameter here, and the response must be sent in under 5 seconds. Then, finally, the response from Sharepoint will be created. At this point, your subscription will be valid and live. Now, let us take a look at how event processing happens in this scheme. Once an event has been raised on Sharepoint side, it doesn't matter which kind of event. It could be an update, a deletion, or an addition of a certain item. And the reaction of our webhook is always asynchronous. So we are reacting to a done event. We cannot instruct Sharepoint to cancel that event. So basically, webhooks are acting as a asynchronous remote event receivers in this instance. So a change has been done in Sharepoint. For example, a user has uploaded 10 documents in a batch. Upon receiving the post notification from SharePoint service, we immediately send back 200 OK, but then asynchronously we also store our intent to process changes in the storage queue, which is a part of Azure. A web job can be configured to listen to new intents in the storage queue and act upon them. So when we add new item in our storage queue, a web job will be instantiated and run for that item. And inside that web job, we will query the list to which we are subscribed in the SharePoint service using the client-side object model API or REST API. SharePoint will respond us with a list of the changes which have occurred since our latest call to the same method. So each call to get changes method is basically asking to give us a set of changes which has occurred since our previous call, and then we process the changes. Let us go through the get changes pattern once more in more detail. We firstly grab and store the first initial current change token with the subscription. Then we persist that into a storage medium, like an Azure database table. Once our post notification from SharePoint arrives to our webhook, we push a new work item into a storage queue. And as I've told you, a web job will get created for each job item, and then the code inside the web job will get the latest token from the storage medium and include that with a call to get changes to the SharePoint. This way, SharePoint will know from which point of time to return the list of changes. And then it will also, along with that list, push an updated changes token, which our web job, upon processing on the changes, would then again store in the storage medium, so that the next iteration of our web job would get a renewed token. So in this demo, we will prepare our Azure portal for the future code, which will contain our provided hosted add-in. We will provision new Azure SQL server and database, create a new Azure storage account, which will be responsible for storing our work item, so it will contain the queue of our work items, and we will configure Azure SQL database using our offline SQL Server Management Studio, which is a free download available at microsoft.com and is used to issue queries to the SQL servers. Let us get started. First, let us create a new web application which will host our provider-hosted add-in. Let us go to New, Web plus Mobile section, and then Web App. We will create a new resource group for that and click Create. You will see that deployment will be in process for this item. When deployment was successful, we need to go inside our application settings and download the publish profile from here. We will use this file in the later videos to add to our provider-hosted add-in solution so that we can publish the code using these settings, and they will fall nicely into this space. Next, we need to create new SQL Azure server and then the database. We will use existing resource group. At this point, we need to go to the server and create a new server. Once we have specified the parameters for the new server, click Select. And finally, we can click Create. You will see that the deployment will be in progress for some time. Let us go inside and wait until deployment has been completed. After deployment has been successful, We need to go inside our server and then inside our database. We will see a server name here, which we need to copy and paste to our SQL Server Management Studio. Let us do that now. We need to select Server Authentication here and provide our password and username. As you can see, we do not have access. Our IP is blocked from accessing this server. We need to go to the firewall settings in our SQL Server in Azure and allow our specific IP address to connect. Let us do this now. Let us click on Set Server Firewall and add our IP. At this point, our IP has been added. Let us try connecting again. Once we are connected, we need to run 3 SQL files in succession. The first one will create the schema, so tables in our database. Let's run that now. The second one should be run against the master database, and it will add a login which we will later use. That's done too. And now we can assign said logging to our database and add some roles to it. We are all set. There is one more thing to do in Azure portal. We need to create a new storage account. Give it a name. For now, let us select the classic deployment model. Use existing resource group and create. After our storage account has been created, we are done with Azure portal configuration for this video.